record. All right, so first up is number 15. And I'll just do them in the order that you ask for them. So number 15. And just like you, the first thing I'm going to do is I'm going to copy it onto my separate paper. And this is x minus 3/4 equals 37 over 12. This is a topic that actually didn't quite get addressed in yesterday's lecture. We did talk about fractions yesterday, but we talked about them very specifically in the context of how to multiply fractions. So this is a great, great refresher from the good old days. First off, fundamentally, this is an algebra question. This is not a math question. Algebra question. What do we do to solve this? You don't have to know how to do it, but there's a very correct answer. What will I do to both sides? Yeah, Gunnar? That's what I would have said if I sat through yesterday's lesson too. But I need to ask you guys a question. What is that? What is it? That's a subtraction sign. And how do you kill subtraction?
Addition.
With addition. So this actually is not a flip it over problem. This is a good old fashioned, this problem at its core is no different than the one I'm about to write in yellow. If I gave you x minus 4 equals 8, you would just add 4 to both sides, right? We're going to do the exact same thing, only it's going to be a little bit harder because we got to do the F word, fractions. So I'm going to add 3/4 right here, and I'm going to add 3/4 right here. That is not math. You don't even have to know anything about mathematics, so to speak, to do that step. That's just procedure. C minus, do plus, C plus, do minus, whatever. Now we have to do math. So first, let's do a little housekeeping. Let's drop our x and let's drop our equals. Now let's go all the way back to the, I'm going to pour some coffee for this because we got a big bridge to cross here. All the way back to like 4th and 5th grade. Do you guys remember how to add, not multiply? Multiplying is and dividing, that's a flippy thing. How do you add two fractions together? Go ahead. Oof, there it is. You have to have a common denominator. Remember that fractions are only compatible for plus and minus if the bottoms are the same. And right now I'm like, well, great. These isn't going to work. So what I have to do is I have to say, okay, 37/12, I need your partner down here to be compatible with you. In other words, I need 37/12 to try to add to another fraction that has 12 as its bottom. If the bottoms are the same, no way. So you think to yourself, okay, in that bottom fraction, the one that used to have a 4 on the bottom, what did I do to the 4 to make it a 12? I multiplied it by 3. And if I multiplied the bottom of that fraction by 3, I multiply the top by 3. And guess what? We now have a pair of compatible partner fractions. If the bottoms are the same, then all you have to do is keep the bottom the same for your answer and add the tops. What's 37 plus 9?
46.
46. If you were to leave this answer on a quiz, you'd lose a half a point. But if it were a 5-point problem, that's still pretty good. That's a 90%. Why would you lose a half a point?
Not reduced.
Because you didn't simplify. And a lot of times kids come to 9th grade with me and they think simplifying means oh, it's bad because the top's bigger than the bottom. We love fractions where the top's bigger than the bottom. We have no issues with improper fractions, but what we all take issue with is the fact that both of these numbers can and need to be divided by 2. That's simplifying. Simplifying isn't converting it to a mixed number. Mixed numbers are stupid. We don't want those. But what I do want is x equals 23/6. That's perfect. Did that answer your question? You okay?
4 minus 2 plus 2.
The down here, the purple?
Yeah.
Those are division signs. So all I was doing was taking a fraction and reducing it. So I divided the top and the bottom numbers both by 2. Fractions should never be unreduced. If the top's bigger than the bottom, that's fine, but they should never have something that they can reduce by. And so since those both could divide by 2, That's always going to be a thing. Any math you ever take from like eighth grade on, every fraction should be reduced. It's no different than if you had like 6/8, how you'd reduce it to 3/4. Same idea. Is that better? You said number 8. Any other questions on 15? All right, number 8 is up next if anyone's interested. By the way, if I look around the room and I see you ignoring me, I'm not going to give you grief because I'm going to assume that you're fine. You don't need to go over this one and you can work on your own. So I'm not going to like judge you. But I'm going to be talking, and if I see all of you listening, then that means you're great. You wanted help with this problem too. I won't take offense. I will take offense if I have to talk over you though. So number 8. Oh, you guys are going right to the fractions. All right, so this is from the lesson. We learned that, well, first off, the 5/7 is who we want to get rid of, right? And since it's not plus or minus a 5/7, then we know it's a times. And remember from the lecture that when we want to get rid of a fraction, we multiply by the upside down.
So 7/5.
So 7/5. And it's beautiful. The reason it works is because the sevens, we set it up so that the sevens cross cancel and the fives cross cancel, and the algebra is done. My job as your algebra teacher is over. You have x equals, the equation is solved. But now what happens is we have to actually do some arithmetic, some math. Do you remember what to do a whole number times a fraction? Right. So let's head off to the side and put the 20 over 1 and multiply it by the 7 over the 5. I said yesterday that some people like to just go straight across. This is a bad time to do that because really what I want from you is to never use a calculator. My goal for you is to say how much of this can we do. So here's the trouble is if you go straight across, you get 140 over 5. And then you're stuck trying to reduce that and you're like, oh, that's nasty. And I'd rather you do it without a calculator. So yes, and that's what I always want to quite smaller numbers, it doesn't matter, but with stuff like this, take it. Take the 20 and the 5, divide them both by 5, and you're left with a 4 and a 1. And now is when you have to smash it together. You go straight across the top and you go, okay, 4 times 7 is 28. 1 times 1 is 1. 28 over 1 can, of course, be written as just 28. You're so welcome. Yeah,
You just go back up to number 15.
I can. Is there something on there that you'd like to discuss? Because it's
No,
it's really important that you allow me to help you.
I'm just on 16. Similar. Yeah.
So tell me about your algebra, Rowdy. What have you done on number 16?
Added 7/4 to both sides.
Okay, so you should be looking right now, and I'm just going to not show the whole algebra. I'm just going to help you with your math. So off to the side, I assume you have a 27/20ths, and you're trying to add it with a 7/4.
Yeah.
Am I doing okay? What is the least common denominator? Like, what do you want them both to say? Now, that's not going to work. You need to understand that a least common denominator will never be smaller than the biggest one. So when I ever ask you again for a least common denominator, the smallest answer you could give me would be 20. Okay, you're thinking of something called the greatest common factor. It happens all the time, but I need to know what can both of those fractions have as their bottom. And I look at it and say 27/20ths. I'm going to just leave you like you are. Let's see if we can turn.
Oh, times 7 by 5.
Yes. And because the least common denominator that we want is 20.
Yeah.
I always say if I can turn one into the other, that's a bonus because then I don't have to change them both. Score. So if we go times 5, we get 35. And then we add 27 to 35. And how many 20ths are you going to get?
The
Kudos on the mental math. Much appreciated. So you're going to get 62 over 20. And this is the exact same thing I told you on the last problem. Your answer is not wrong. It just sucks. Like, if you got to reduce, right? It's perfect, just not done. So what can 62 and 20 both be divided by?
Cool.
Start with the low-hanging fruit. Take the 2, right? Like that's obvious since they're both even numbers. And sometimes what you'll find is you grab a 2 and then you go, oh, oops, I could.
31,
Yes. And whenever you divide by a little baby number like 2, you get your reduced. Sometimes you just look at it and know you're done. But sometimes you look at it and go, I could have gone bigger. That's okay. You just go again. No biggie. How'd that feel?
Bad.
All right. Not too bad. What other questions do you have for me? Tyler, what is your question? Yeah. And FYI, if I'm ever looking around the room like a dingbat like that, you can just, you don't have to, you're so polite to raise your hand, but honestly, you just got to yell at me. It's all good. You said 17? Sure thing. Uh, I will talk to you a lot about the fact that I don't want you using calculators. It's funny because I tell you to go buy them and then I tell you I don't want you to use them. But the reason I want you to have them is because you should use it for this. Because first off, there's two sides to my lesson every time. There's the algebra side, and then there's just the basic math side. Let's talk algebra first. The algebra question is always, what are we going to do? In this question, this is his question, but we can all answer. What do we have to do to both sides on this equation? Yes. So knowing what to do is the algebra, the process. So let's set it up first before we go, oh, crap, this is nasty. So we're going to divide both sides by negative 13. Showing your work and setting it up is like step one. And doing the housekeeping stuff is kind of like part of step one. Drop your M and your equals. Now you're like, oh, holy smoked ham on a sausage. Like, what am I going to do? Well, we're going to probably bust out our calculator. First things first, let's talk basic skills. What do I know a positive divided by a negative is going to be? It's going to be a negative. So what I like to do is just write the negative. Now, right there, you don't have to type the dumb negative in your calculator. So go ahead now, grab your electronic calculating device and type in 182 divided by 13. What'd you get?
-14.
So it's negative 14, and we're done. You'll find occasions where using your calculator is completely understandable. I should not look around and see you using it for -4 times 9, 11 minus 20. You know, rinky dink stuff. That should be stuff we do in our heads. Did I answer your question there, my man? You good? You sure? You know, I'm slacking today. I keep forgetting to do something really important, and that's box up my answers. I'm gonna have to give myself a lunch detention here.
You're in your
I know. Is that you? Yeah. Mhm. You can divide by fractions. So 11. I have a conversation that I'm going to have with one person specifically, and the rest of you are welcome to eavesdrop. I never address this unless someone asks it. So this is in regards to problem 11. And there's an 81.2% chance that what I'm going to say might not make any sense. You've been warned, okay? So here it goes. The question is, do you always have to multiply on problems like this, or could you divide? Listen, in theory, you should divide. But according to your math teacher, Mr. Bully, you should multiply. So let's talk about why the contradiction. Here's the deal. Whenever a math equation comes with a number attached to an x, theory says you should divide. But I want to walk you through division in hopes that you'll understand why I don't do that. So here it goes. If it said 4x equals 24, I divide both sides by 4. Easy peasy, right? So I'm going to do it. I'm going to divide by 3/8. Good. And I'm going to cancel out these 3/8. And then I'm going to bring down the x, and then I'm going to bring down the equals. And I'm faced with a math problem now. I'm going to write it down for you. I'll write it in green. It says -9 divided by 3/8. I know at some point in your years before you met me that someone taught you how to divide fractions. And I'm guessing that they used an expression, the one I hear a lot
M dash.
is copy dot flop. I'm guessing you heard an adult say that. And the reason we say copy dot flop is because it helps us remember that the way to divide two fractions is to copy the first one. In other words, leave it alone, change the division sign to a dot for multiplication, and flop the second fraction, right? So here's what I'm going to do. I'm going to take the -9 and write it as it used to be, -9/1. That's the copy. I'm going to change this to dot, and then I'm going to flop the 3/8. You see that? Okay, so I'm going to now explain to you why I don't divide. The answer is, could you divide? Yes. But in reality, wouldn't it have been quicker if we just got right to the dot flop step in the first place? So that's why I take 3/8 and I'm like, let's just get rid of the middleman and just cut right to the chase. Boom, like that. Do you understand that? So we are dividing, we're just skipping the middle step to be smart about it. Save 30 seconds. Yeah. Rack. Good answer.
For a second, I thought you were gonna say that you would just get a hold.
Absolutely get the same answer. It just saves a little time. We're going to get to times the reciprocal anyways. Might as well just jump in. Yep. What's up, Chancy? Number 20 has been asked about. Yeah. Number 20 says that 10/7 of some unknown value n is equivalent to -6 1/4. I am not going to divide as per my explanation just now. I'm going to cut that middleman right out, and I'm going to do the multiplication by the flippy flip. So I'm going to take 10/7. I'm going to flip it to 7/10, and I'm going to apply that on both sides like this. And for the record, we have done exactly zero math to this point. We have merely followed directions. Procedure. We're still just going to be in procedure mode. We're going to cross out the 7s and the 10s. We're going to bring down the n and the equals. Now, you cannot get away from the fact that you have to be able to do basic mathematics. So here it goes. Over here, I've got a lot going on. First thing I know, and I'm going to write this, and I'm going to write it in green, or I'll use purple so you can see it. I know that my answer is going to be negative. One thing I like to do is just do that first. Because I'm about to get so wrapped up in dividing numbers and all that crap that I might forget the negative. So I just put it now, early, and then I can go worry about the numbers. So here it goes. What you don't want to do is what I'm about to do. You don't want to go, oh, 7 times, if I had 7 quarters in my pocket, I got $1.75, and then 4 times 10 is 40. Because now you got to reduce that behemoth fraction. I don't want to do that. You don't want to do that. So we can avoid jumbo fractions if we reduce early. So let's go back in time and let's look for guests on the top floor and the bottom floor that can reduce. Yeah, I'm seeing you holding up a 5, and I'm there with you. This 25 and this 10 can both be divided by 5. So I'm going to knock the 25 down to a 5. I'm going to knock the 10 down to a 2. The survivors are the 5 and the 7 and the 2 and the 4. So I'm going to ask you again, what numbers from the top floor can reduce with numbers from the bottom floor? What numbers from the top floor, 5 and 7, could reduce with a 4 and a 2?
A 2,
Nope.
1,
Nope.
none.
None is the answer I wanted to hear you say. None. Whenever you can look at a problem and say there's no more reducing to do, you've taken whatever you could get and now you just suck it up and multiply. And I'm guessing the reason I got this question is that she already knew this. She just got to the end and thought maybe she did something wrong. The answer is, quite frankly, -35/8. It is what it is. Fractions sometimes just happen. That address your question? You're so welcome.
We love you, Mr. Ahern.
Oh, that was nice. Doing okay? Okay. 22. I was not surprised to see that there would be some fractions involved, so
It seems fairly simple.
this is off the chart simple. And the reason I wrote that little dumb thing at the top is because every once in a while the math gods just throw you a little bonus bone. Um, so here's the deal. There's a fancy way to do this problem, and I'm going to show you right now. And I say this a lot, but this is, again, something that at some point in your career, be it seventh or eighth grade, someone probably showed you this. And who knows if it's stuck. But there's this thing called cross multiplication. And the method I'm going to show you right now is good to know, because when the second method I'm going to show you doesn't work, then you need to have a backup plan. Here's your backup plan. This is how you do it, my friends. What this is called a proportion. Anytime someone gives you an equation that's a fraction, an equal sign and a fraction, it has a name. It's called a proportion. And to solve a proportion, what you do is you cross multiply. So here it goes. I'm going to use some colors and I'm going to ask you, what is the answer to 11 times n?
11.
It is 11n. It is what it is. What is the answer to the red problem? 4 times 33. It is correct. It's 132. All right. Now, the thing about proportions is this. If there's an equal sign in between two fractions, you can take this to the bank all day long. Those red and yellow answers have got to be equal. Proportions are not to be disrespected. The diagonal will always equal the other diagonal if it's a fraction and a fraction. And now I got myself an easy peasy equation. I got to just divide both sides by 11. Oh, easy, easy. And the answer is n equals 12. If you got that, that's good news, because that's your backup plan when what I'm about to show you doesn't work. You ready for the easy way? Yeah, here it goes. I'm going to hit the back button a bunch of times and we're going to start over. You're going to probably be like, wow, that was really stupid. But again, this won't always work. Just think of this as two fractions. Look at the bottom. What does 11 have to do to become 33? Times 3. What's 4 times 3? There's your answer.
Jeez.
But I know, right? It's like a joke, but I don't show you that way first, because check out something like this. What if I give you 5 is to 8 as n is to 12? Now you're screwed, right?
Yeah.
Because now if you try the cute little arrow sideways method, I say to you, how does 8 become 12? And you're like, I don't know. So this is where our backup plan is to use the cross multiplication. Does that make sense? So cross multiplication is your backup. Going sideways is it's pretty easy.
Kind of an option if it works.
You good, Hanson? All right. Yeah, it's a great option if it works. What's up, RB?
Question 18.
Tienes que decirlo en español, el número. ¿Cuál problema?
Gracias.
You have to say 18 in Spanish.
What's 11?
It's irrelevant.
Yeah, and you say 8.
What's interesting is that
Uno nueve.
you're crushing my will to live here, Rowdy. So when you say numbers in Spanish, there's a special number for 10. That's diez. And then when you start counting after 10, there are special numbers for a while. 11 is once. It gets its own thing. 12 is doce. 13 is trece. 14 is catorce. 15 is quince. But hold on. After that, all the cool stuff runs out, and we just default to like 10 and 6. So like 16 is dieciséis. 17 is diecisiete. So what's 18?
12.
Oh my.
Nueve. Nueve.
Oh boy. It's not going well, is it?
9.
18.
Oh, it's nine. Uh,
I'm sorry. Let's go over problem 18.
no wonder I'm trying to go into Spanish.
I guess I'll just say this on the recording, and you can argue with me, but you'll lose. I think that you all should take Spanish. And I don't say that because I have a love of Spanish. I say that because I have a love for young people. And you guys all someday are going to, as young people, you're going to have to go out and find jobs. Do you get that?
Yeah.
And someday, in a world, in a country specifically where our Hispanic or Spanish speaking population is growing consistently, constantly, I believe in my heart that you're going to be more employable at some point in your life. You'll still be young people when you're 22, 23, and you go to get that first job you want, that's in the city you want, with the hours you want, and the pay that you want, and the benefits you want. If you and someone else are equally qualified for the job, there might be a really beneficial position to being able to speak just a little bit of functional Spanish. So my take, lecture almost over, is that every one of you should learn to speak some Spanish for that reason specifically. And it's fun. Anyways, let's do problem 18. What are we going to do?
Times it by 5.
I couldn't agree any more if I tried. And remember, in algebra now, we show times with parentheses, and we're going to multiply both sides by 5. And on the right-hand side, our 5s are going to go kaput. And then we're going to dutifully drop down the n and drop down the equals. And what is 5 times 20?
100.
And you, sir, are done.
That was a lot easier than I thought it would be.
You're going to find that to be the case a lot throughout this school year. So, yeah, Jency? So
So it's like, so I can put.
I do. It's over there. That's funny because I almost got rid of the hole puncher, and then I was like, someone might want it. So there, day 3. Yay, me. We're gonna go over number 23 first, and then I'll get to 12. Because I added 3 to both sides. To get rid of the -3, I added 3. And I do know that there's a plus sign there, but it's still a -3. So that's, you add 3, you should be good to go.
That's basic.
5.
I would say that question 23 is probably one of the harder ones on here. So, yeah.
100. 100.
I am going to pause the recording for a quick second here so I can address something. The question is 23, and how do I even start? So let's talk algebra. Algebra first. What do we do to both sides? Subtract the number that we want to kill, right? So we clearly want to get rid of 14/9. It's not a multiply, so this isn't a flippy times problem. This is a subtract problem. So we're going to take away 14/9 on both sides like this.
I have a question.
Mhm.
So I know how you like to still prime on order with the math problems. If you know that you're gonna subtract it, why don't you just like cross out the 14/9? Instead of just
That's a great question. Why do I make you show this much work? Is that kind of what you're asking? No, you're not wrong to ask, and I don't consider it like a defiant question. I struggle with this over 29 years. I've gone back and forth and back and forth. And what I learn every year, I'm not making this up. Like every year, there comes a point in usually early October where I say, okay, they've got it. I'm going to let them start showing less work. And it's amazing how instantaneously the success rate falls through the floor. So what I've learned about this, whether you believe it or not, please trust me. I won't ever make you do something that I don't think is in your best interest. What I've learned is that not being meticulous about our work is going to cause us to add when we mean to subtract. I get crazy answers. And then when I ask a kid, like in the middle of November, to say, hey, let's go back to August. I want you to show your work like we used to. Then they go, oh, I see what I did. So there is a reason. There's a method to my madness. Is it annoying as all get out to keep doing this? Oh, yes, but it's good for you. I promise. Okay.
Will we ever get to a point where it'll just be like that?
Where we just, yeah.
I can do it like that, but all the work is just.
I'm going to pause. Maybe, no, I'm not going to pause the recording. I know you asked about this question. I'm going to go on a quick side detour. Give me just a quick moment. I'm going to keep this fast. There comes a point, and I was just talking to Natalia about this, but like there comes a point in every school year where and every year I wish I had it back. I wish I could bring the words back in. It's usually October. And I tell kids, you know what? We've done it. We've graduated. It's time. You don't have to show your work anymore. And it's like as soon as I take that leash off, within 2 hours, I'm not kidding. I don't make this stuff up. I give a kid this problem. They go, oh, I don't have to show my work anymore. This is so rad. Whew, X equals 6. And I'm like, all right, that's it. And why did I do this? And every year I wish I could take the words back because kids like, what? 10 minus 4. And I go, see, prove my point for me. So I'm going to hold on to you as long as I can to ensure that you don't ever do. And if you don't see what I did wrong, by the way, I'm probably talking to you. What should I have done to both sides? I should have added 4. And the moment we let ourselves stop seeing this, crazy things happen, man. So that's why I'm the way I am. All right. So stay with me and keep showing your work. What? Oh, are you ready to do this problem? Okay. So was this your question? So first off, we need a common denominator, and the denominator clearly is going to be that I want to turn this fraction into one that has 9 as its bottom, right? Okay. So I had to do times 3 on the bottom, so I'm going to do times 3 on the top to get 21. See the magic? And now the denominators are the same. So really you just have to perform the mathematics that's in this yellow box. And what is 21/9 minus 14/9? So n is 7/9.
That's what I thought.
Right. I gave you a full hour, 45 minutes today to work on this. I expect the next time I see you that these problems will be done. That's usually how it's going to go is you got your 45 minutes. We went over, I think, probably almost half the worksheet together. When I see you again in 23 hours and 15 minutes, I will have another assignment for you. Got it? Is everyone listening? Do you understand the task? Brad, you can hold on to it if you want. That's fine.